In this question, we are given that a projectile of mass m is fired so that the horizontal range is 4 kilometers. It is saying at the highest point, the projectile explodes in two parts of masses m by 4 and 3m by 4 respectively. And the heavier part starts falling down vertically with zero initial speed. And we are required to find the horizontal range of the lighter part, that is distance from the point of firing. So here we can visualize, as we know in case of explosion of a projectile, we already studied in theory that the center of mass of the exploded particle follows the path of original projectile. So here we can see if there is a projectile which was say fired with a speed u at some angle theta such that its range is 4 kilometers. Now in this situation, the mass m at the topmost point, which is exactly midway between this 2 kilometer and this also 2 kilometers. Here it explodes in two parts. One is m by 4, other is 3m by 4. So it is saying the heavier part, which is of mass 3m by 4, it starts falling vertically down. So 3m by 4 falls down and its initial velocity uy will be 0 because at the point of explosion the initial speed was u cos theta. So it did not have any y component velocity. So in explosion linear momentum remain conserved. So the particle 3m by 4 as well as the other particle, which is m by 4, will not have any vertical velocity. So this will have a horizontal velocity v such that the momentum remain conserved. So here you can see, by conservation of linear momentum, here we can write initial mass m multiplied by u cos theta was the initial momentum in x direction, and after explosion x direction momentum should remain conserved. So it is m by 4 times v, which gives us the velocity as 4 times u cos theta. That means here the velocity is increased to 4 times in horizontal direction. So it will certainly go far away. But it will also not be having any velocity in y direction, so it will follow a projectile path and will land somewhere here on the ground. Now there are various ways of solving this question. If we solve it by using the initial velocity, we can see the time of fall is same, which is the time of rise. So the distance which it has traveled in time of rise is 2 kilometers. Now the velocity is 4 times, so the horizontal distance it will cover in the same time of fall, which is equal to time of rise, the distance traveled will be 4 times. So if it is 2, then from here it will fall at a distance of 8 kilometers. So this is 2, this is 2, then this will be 6 kilometers. So here what we have drawn, the figure is not to scale, so you should not worry about this, as this is small, this is large, so this is not on a scale, but this distance is 6 kilometers, so distance we can write as 10 kilometers. Or even if we consider this distance as x, then other way we can calculate, it will fall at such a point so that the mass m by 4 and the other mass 3m by 4, which are falling at the same time on ground, their combined center of mass must be located at this point. So we can write 3m by 4 and m by 4 will fall on ground such that their center of mass is located at the original path of projectile that we already discussed in theory. So we can see if this is the center of mass, then the mass moment of these two is 0. So here we can write 3m by 4 multiplied by 2 kilometers should be equals to m by 4 multiplied by x. Here you can see value of x we are getting is 6 kilometers. So the total range can be written as 4 plus 6 is equals to 10 kilometers. So here you can see the answer to this question is option C. So we can write answer to this question is option C. So this we have calculated by two methods. One is by verbally analyzing the time of rise and time of fall is same. So the distance covered after explosion by the mass m by 4 is 4 times that of the initial distance covered, by which we are getting 10 kilometer. And by another method of center of mass also we are getting the same result.